I probably have the strangest case I've ever had in my career. This truck here come in with basically kind of 3 complaints. One was his key fob doesn't work. 2, his interior dome lights don't work. And 3, he has a intermittent StabiliTrak issue, and he also is losing Prindle and things like that. And history on the vehicle, he bought it this way. Yeah, he just bought it and it was like this. So let's get into it. So I'm already pretty far along in this diagnosis, so I'm just going to catch you guys up real fast. When I got the truck, I drove it just up and down the street real fast to see if I'd get the StabiliTrak to act up. It didn't do that. So I attacked the known bad all the time issues of key fob not working and dome lights not working. So when I checked everything, the radio control, what do they call that? The radio door lock control module, I think. Basically, it's the module the key fob transmits signals to, is in the back corner back here. I might actually still have it hanging out. I'm not sure. Nope, I got it stuffed back in there. It is right here. It just kind of sits in there. It's got some clips. Pulled that loose. Checked my power, my ground, both of them good. Checked my data. Checked it with the scope. Clean, perfect data. So kind of looks like that thing is bad, but we're not replacing it yet because we have another issue to diagnose, which was the dome lights. And I'll pull up a screenshot of the diagram for these. These get power from the BCM. So basically circuit tested everything down at the BCM, had no power coming out of the BCM. Checked all my powers to the BCM, everything was fine, no blown fuses, nothing like that. No real reason the BCM should have those circuits turned off. It can turn the circuit on and off, so, but no real reason for it to. I even had it in live data. It was showing that it was on, but nothing coming out. So that pretty much confirmed bad BCM. I went a step further. I tried to flash it, reprogram it, whatever you want to call it, to basically see if it would reset it and get that function working again. And that is when I 100% confirmed bad BCM, because when I tried programming it, it wouldn't go through. It wouldn't even act like it was communicating with it, even though ScanTool would communicate with it and everything. So, got him a BCM. Also a ground cable, because somebody had hacked the ground cable up. Got it laying over here on the bench, just where I had it took off. They cut the end off and put these on it. Yeah, so we got a new ground cable, because I don't like people messing with ground cables like this right here. They had that attached to this. And I've seen, oh yeah, one of his complaints was when the StabiliTrak acted up, his door locks would lock and unlock. If you've done a lot of these old Chevys of this year range, this is a 2008 Silverado, so you're pretty familiar with ground issues with these things. The ground cables get bad, and they will cause that. Well, they will cause the door locks to cycle. You'll get some random lights on the dash. So we went ahead and got him a ground cable. I got that put on there just in case that was what was causing his intermittent issue. I don't think it is anymore. We also got him a brand new BCM. I put the brand new BCM in here and programmed it. Everything was all good and fine, and then as soon as I started the truck, the module died. It went no communication almost instantly. Like that. Like it was crank the truck, no comm. Yeah, very strange. So I've now put a brand new BCM in this thing that died as soon as I started the truck. Let that sink in. It's actually right here. This is the brand new one. I took it out of the case because I wanted to see what happened to this thing. And the only thing that I seen, I've already kind of put it back together, kind of, to plug it back up into the truck and so y'all can see this thing. But there was a, this chip right here handles a lot of the functions, basically the on-off functions and processing and stuff. There was a surface mount resistor, kind of basically looks like these, but it was right here, and it was a 10 ohm. So it's basically a power limiting resistor going, supplying this, I guess, with power. That was blew up. So I've soldered another 10 ohm resistor in there just to let the circuit power this again, because we're going to plug this thing back up and see what happens with this. So yeah, let's figure out what happened to this BCM and the other BCM. By the way, I didn't notice it at first, but the other BCM that I took out of this thing was brand new too. So somebody had this issue, had it diagnosed, they determined the BCM was bad, they put a brand new BCM in here, and then it instantly died again. And then they sold the truck that way. Yeah. So let's plug this thing up real fast and see if it lets the smoke out again. It might not, or it might, I don't really know. I do know this will not crank the truck. So I'm not sure if I can get the truck to crank again. I've got another BCM to replace the replacement. And I have had the truck running. I've actually narrowed my issue down to a wire, but let's look at this thing. All right, so keys laying down there on the floor. I've got this thing plugged up, and we're actually going to look at it with the Topdon TC003. I think that's what this is. Not real sure. But we look at this sucker. We can see we've got a chip there. It's already at 250 degrees. 250 degrees. All right. And another part of the board over here, 201 or something like that. It's kind of hard to, yeah, 201. So, yeah, that thing is cooking. And we've got the key laying here on the floor. So, yeah, if I stick the key in here, we've got no comm. It will kind of turn things on, not a whole lot, but yeah. There we go, kind of coming on. You see we've got no prindle, we don't have the line under the park, and we're no start. And let's see, we're still standing around that 250 degree mark. So yeah, that is this chip right here. It is, yeah, pretty hot. My resistor is holding up. It's not warm, but yeah, that chip is definitely hot. How would you guys feel about getting this truck? That module, you guys always want to know about process, and I hate going over process. I really do. I hate it because process varies so much. I think I'm probably going to do a whole video just for you guys on pricing. But my cost, what I paid for that module after taxes, is $392, and there's a $25 core charge. So take $25 off of that. It's not a cheap module, really. It's $370. My cost, what I paid for it. Yeah, up in smoke as soon as I started the truck. So now we got to dig into this thing and figure out what killed my brand new BCM so it doesn't kill my next new BCM. Alright, so of course you want to go through all of your powers, all of your grounds, and make sure 100% they are good and fine, nothing wrong with them. I did that. I went through all of my powers. There's probably like 7 powers, I think, that feed this module. Only 2 grounds or 3 grounds. I think 3 total grounds, I think. Not very important. Then what I did, I went through every single pin testing for shorts to power and shorts to ground. And I'm going to show you kind of how I did that. And anytime I had current flow, I looked up the pin on the connector to see what it went to and if that was acceptable or not, and then give it varying amounts of current to know, yes, it's within the range or not. So we'll go over just a few pins, kind of show you my process on that. And I'll just tell you which ones I narrowed it down to, basically. All right, I hope I got you guys in the frame, but if not, sorry. So, got our meter here. We're just gonna have it on volts. We're using my stackable leads. Let's see, where's my other end? There we go. Okay, so meter, my low impedance or high impedance test light, so very low current. So this thing is going to light up anytime it has current flow, basically. So it's going to take 50 milliamps to light this. So 50 milliamps is flowing on the circuit. This is going to light up. And like I've told you guys, this thing is module safe. So if there's something else in the circuit that shouldn't have power, 50 milliamps is not going to be enough to damage it. So yeah, we're just going to pin this into my voltmeter here. I hope you guys can get in the frame here. Hopefully you can see it. I know I got kind of just a spaghetti of stuff going on here, but it is what it is. And I'm not even sure you guys can see anything because I've got you crammed in a corner there. But I'm just going to use 2 back probe needles. So I'm going to stick my power side into a power here, and we'll give it a ground. This is a ground, so you can see, stay in there. So you can see the light is bright, hopefully. And you can see our voltage right here is 12.25. Okay, if I take the bulb out, you can see we're still 12.27. So the load of the bulb is only dropping it maybe 2. I don't even know what that decimal point is. Microvolts? I have no idea. 2 microvolts. So if we see this light up completely bright, we basically know the full amount of current is flowing that this bulb can handle. Okay, I hope that makes sense. We're going to get to some pins where this is going to be a little dimmer and we're going to see a lower voltage, and we'll get to that. So we're going to leave this in a power and basically check some of these for grounds. Basically, that's what I did. I went through and checked every pin for a path to ground. Okay, so I've got power coming in. It's hitting my light bulb. It can jump across to the ground side or the negative side of my meter. So I really hope this is making sense. But if I touch this to this pin here, you can see that lights up and we've got 12.23. Well, that means this pin is a strong enough path to ground that it allows my test light to light its brightest and flow its maximum amount of current. All right. So if we change this bulb out to this, I already know what this circuit is. It is a light, I think tail light, I think. One of the turn signal bulbs, I think. Can't really remember. Trust me, this is safe because this is a light circuit. So now we're going to give it a varying amount of current. So use a 1/2 amp bulb. Okay, and get my probe back in here. So you can see now we got 11.6 volts here. Hopefully you can see that. And this bulb is completely bright. So you can see how the current draw of the bulb has lowered this. That means there is some resistance in the circuit somewhere. All right. If I go to another 2 amps, so it will be a total of 2.5. You see this gets really bright, but yet our voltage drop is now down to 6.7. Okay, so that is telling me in this circuit there is resistance. If there wasn't resistance, if this was straight ground, this would still be 12 volts. So let me show you. If I take this out and I touch this up here to bare metal ground. Oh man, that's bright. Can you guys see that? I hope so. It says 11.6 and my needle is getting hot. So yeah, hopefully that makes sense. You see now we're not as bright, 6 volts. There is resistance in that circuit elsewhere. And since I looked and I know this goes to tail lights, I think. Let's just look. I don't remember for sure what that was. I'm pretty sure it's turn lights. Yep, tail lights. Okay. So just so you know, we'll take it and we'll undo this. See, no more. So I'm hoping you guys are following me here. Oh boy. I know, this is probably gonna be terrible. But hopefully that makes sense to you. That bulb is hot. That circuit has a path to ground, but it's got resistance in it. So I'm now deeming that safe, okay? I've went through this entire harness doing this same procedure, and I don't really think there was any other ones other than light circuits. I think maybe a relay circuit. We can check, and you can kind of see how a relay reacts to it. We'll get our voltmeter or low current bulb back in here. Let's see. We got to try to remember what's what here. Okay, this is a good one. All right, you might not can see this, but this is glowing just a little bit. Hopefully you guys can see that. And on our voltmeter here, we've got 3.5 volts. So that tells me that circuit is a path to ground, but it is extremely high resistance because this isn't lighting up bright, and we've only got 3.5 volts here. So that circuit's fine. I looked it up. I don't remember what it is off the top of my head. I really don't. Sorry. But this is not a short to ground, so that circuit is fine. I'm hoping this method is starting to make sense now. If we move this over to another pin here, See, this one's got 2 volts. This is even dimmer. Let's see. That's 0.1 volt. It's not even lighting up at all. So hopefully this is making sense now. The higher the voltage is here with a load on the circuit, the more of a path to ground it has, the more current is flowing. Yeah, sorry if this is kind of above y'all. I'm trying to explain it the best I can. So basically went through the whole harness, and this is kind of the results that I found. Nothing. Everything completely fine and no shorts to ground. So I then went through and moved from my power to a ground. This has my grounds in it. And did the same process again, looking at, you know, just pinning each terminal, looking for my bulb to light up and voltage. So like if we hit voltage, see we got 12 here, you know, that's what I was looking for through the whole harness. And I don't really remember if I had any or not. There's one, 6 volts. Go back in there. So this one has 6 volts, and remember over here we're pinned into ground, so that means there's power right here. If I take my load out, okay, you see we got 12 volts, 12.2. So this green and black wire in this connector has power on it. But we load that power, okay, we load it, we got a light, and we drop down to 5.8 volts. So what that is telling me is this power cannot sustain a load, like it can't carry current. So if I use a bigger test light, we'll go with just the half amp filament. We see it's not lighting at all because that circuit cannot carry current. If I remember right, that's probably the light switch or something like that. But I don't like putting that much of a load on it because it can burn up the switch or whatever is feeding that circuit. So we use the low current test light. Does that make sense? Why I like this bulb over all my other bulbs? This is not going to damage anything, okay? And I'm not got a good connection in here, but you guys following along still? Hopefully I've not lost you. So went through the entire harness, and this is kind of the gist of what I would find every now and then, something like this, where I'd have so much of a voltage drop that the circuit's not going to carry any current, okay? And I kind of had a head start on knowing that my issue that killed the BCM only happened when it was running. So I looked at my wiring diagrams and I determined the BCM needed 2 connectors plugged up and then 1 terminal and another connector have power applied to it for me to be able to crank this truck and let it run. So let me get my new BCM. I've got it out of the case, but I've got another new BCM to put in this truck, and we'll plug it up and we'll show you how I went about doing the rest of this testing. Alright, so here's my other new BCM. When I was looking over my diagrams and stuff, I knew that I needed the connector with the CAN bus circuits to get CAN bus to the rest of the car, and then I needed the connector that actually goes up to the ignition switch, which is probably going to be hard for you guys to see, but it's this green connector here. This is X7, I believe, or X1. Not really sure. It's hard for me to remember all these connector numbers. So basically, I needed this blue connector because this one has my CAN lines in it. This also supplies the module power and ground for it to communicate. The powers in this one basically are just to supply accessories and whatnot that the BCM controls. So I knew I needed this connector and that one up there. And I'm not gonna lie, I took a gamble. I took a bet, basically, that I could plug these two connectors up and cross my fingers that it didn't fry another BCM. Yeah, I took a risk. I know. I don't know what else to tell you. The issue happened when it started, when the truck started. So basically, yeah, I took a risk, plugged that one in here, plugged that one in here, and I took the thermal camera. Is it still on? Yes. And basically watched the board. You can see, hopefully, my hand in the way. You can see this chip is a little warm and this chip is a little warm, but if you can see the temperatures, yeah, 100 degrees is the hottest point of the board. So the board is not cooking yet. So that is the first thing that I've done, and I turned the button off. I don't like the buttons where they're at on this thing. I always hit this power button, or I always put my finger over the lens because I always use my left hand even though I'm right-handed. So anyways, I basically watched this board for a little bit, made sure it wasn't getting hot. 100 degrees, that is nothing to worry about. And then, like I said, there's one other wire, basically, I need power to for this truck to crank. So with those two plugged up, if I stick the key in, it will not crank. Okay, and you see we've got no prindle. We have no prindle because the wire that we need hooked up is the basically ignition relay. It's the run crank relay. Without it, nothing's gonna work. So I pulled up a wiring diagram, and I might have to pull it up again, but I think it was this yellow wire right here. I think. Let me pull up a diagram real fast, and I'm going to double check myself before I fry something, and we'll get back to this. Okay, yep, I was right. This yellow wire right here feeds our run start relay, basically our main ignition to the truck. So I've got just a little 194 bulb here. I soldered on some alligator clip leads, and these are some for my micro 64 terminal leads that I have. And I'm just going to pin this in here. You might have heard everything turn on. Let me do this again, so I'll be quiet so you can hear it. Hopefully you heard it. And you see we're lighting just a little bit. Relays don't pull as much current as a 194 bulb, so that's why it's not bright. And we want to basically look at our board and make sure we're still not overheating. So, oh man, this is going to be hard to do. Everything keeps falling out. Okay. So let's check our board temp. Hottest spot, 109, still good. And you can see now we've got a prindle. So if I cycle the key, that's going to stay on because run start relay is still on, but now it can crank and run. And this is something I was doing. I had somebody, my buddy Lewis here, he was working the switch while I was watching the thermal camera. Okay. You can see we're still at 110. You can see the rest of the board starting to get some activity. That's completely fine. That board is just doing work. But we're not overheating. 110 degrees, that's really not that much for electronics. It's very, very good temperature. Nothing to worry about. Let me open the door. Probably let all the bugs in, but okay. Alright, so now what did I do? I went through this entire harness again. Every one of these pins again, doing the same test, feeding power through with my low current test lamp, checking for shorts to ground, double checking everything that I checked the first time. And I basically did it one plug at a time. I'd do a plug, verify all of them, plug it up, watch the board. So like this one right here, I went through all these and nothing strange happened, and I've knocked my wire back out. Great. But I went through all of these. Come on, get you guys down. Nope. So I went through all of these, basically checked them all with it running, no issue, and basically plugged it up. Which one is this one? That one. Basically plug it up as I watched the board with the thermal camera. Okay, same thing, nothing got too hot, everything stayed. You can see that's 110, probably not because it's upside down to you guys, but yeah, that was my process. I'd do one plug, check all the terminals, plug it up, watch it while Lewis sit there with his hand on the key, ready to turn it off, and me ready to unplug the BCM before it fried. If I seen temperatures start rising, I was unplugging it and he was shutting the key off. So that's how I approached this. And I basically narrowed it down, and as the luck would have it, the very last plug I got to is where I found my issue. So let me get all these plugs back in here. And I didn't do them in any order. I just basically grabbed a plug and went through them and figured out where they plugged up at, plugged it up, and it was just pure luck that it was the last one that I went through, which was also good because it made me realize that I was definitely on the right plug when I found what I found, and you guys will see that in a second. All right, so I've got everything plugged up except for this one plug, and like I was saying, I went through everything both ways. Short to power was the way I did it first, and then shorts to ground with the engine running. And I found my issue checking for a short to power. So basically had my meter attached to ground and just checking for power, basically looking for power. So just my alligator clip, I just had it up here on some metal. Get the meter back here, hopefully. And I'm gonna go ahead and tell you which wire I found my issue in. So in this brown connector, this pink wire right here, this, when I looked up the circuit, is power supply out to the battery current sensor. Okay, and since I had just put a ground cable on this thing, I'd left it unplugged. Okay, so basically I was figuring out I had an issue And during the process, I just threw that ground cable on there, you know, and I left that unplugged because I knew those circuits went to the BCM. But yeah, either way. So that is unplugged. So if there was an issue with that circuit, it's going to be in the wire itself. And hopefully I can get you guys set up here where y'all can see this. But let's back probe this in here. Come on. There we go. Trying to get it where it'll stay in there. And so I can get y'all to see this. I'm going to hold it here. Okay. And I'm going to start the truck. Yeah. I actually got really lucky because the first time I went through all these, that circuit was still doing that. I have no idea why it stopped. I found what killed my BCM. This is in the current sensor supply voltage, but it still does it when the engine is starting. So I'm almost wondering if it is engine torque related. So let's do some other experiments here. Let's put the brake on, put it in reverse. So nothing, put it in drive. Nothing. Let's give it a little bit of a torque brake. Nope, still nothing. Nothing. But if I crank it again, nothing. Is my connection still good here? Maybe. I don't know. Let's try it again. There we go. So I really just got really lucky that it was doing that while the engine was staying running. Now, we know it's unplugged at the other end. It's unplugged on this end. Where is that coming from? We got to find that. Definitely got to find that. So, got the Varus here. We're just going to hook it up, use a scope on that. I want to see exactly what the voltages are because it was pulsing, almost like an injector pulse or a ignition pulse. But yet we know the injectors on this engine are ground side switched, and the ignition coils on this are 3 or 4 wire coils. They're fed power and ground constantly, and then they are switched with a 5-volt trigger, if I remember right. So you might be wondering, well, what voltage is that supposed to have on it? The BCM actually sends out a 5-volt to that sensor. I don't know if the diagram shows that, but we checked on Lewis's truck. Lewis has a truck basically the same model. He has a 2008 Silverado basically, and we checked his sensor gets supplied 5 volts. So if we've got more than 5 volts on that, it's definitely can damage the BCM. So let's get the Varus hooked up. All right, I basically just have, I still got my leads hooked up the same place. That's just grounded to the metal under there, pinned into that wire and connected to the Varus. We've got this set up here. I'm going to set up a trigger just to help catch this. Okay. Put that down to about 3 volts or something like that. Okay. And we know that we can catch this when it cranks, hopefully. So let's give it a crank. Come on. Stupid keys. All right, so there's key on. We don't see anything. Now let's crank it. There we go, we got it. So, got it paused. Let's zoom out so we can see it. And there we go. Let's zoom in here. So you can see a spike here, and then a few more. Ain't that cool? And we can tell that voltage wise it never goes over 12. So let's zoom this in a little more. Put one of these cursors over this, and you can see right there 10.1 volts or 10.2 volts right there. So that's battery voltage. Battery voltage while it's cranking definitely screams wire chafe issue, but wow, this is crazy. This is crazy. Man, we've got an intermittent chafe to power. Okay, so we know now we've got an issue on one particular wire going to a particular spot. So now we just really need to do a good visual inspection, try to recreate this a little more. I'd really like to get it back to where it was acting up the whole time it was running, but it's probably just not going to work for me. But still, we know that the sensor harness is down here, okay, right here, and that if we follow it around, it is going into this mess where all of the plastic coating, the loom, has fallen off. It's laying on a dipstick down there, okay, and goes up into the harness under the there's a little cover that goes on here and it hooks in there, so it goes under that, into this harness, down under the fuse box. This is going to go in here and up into here or down into here. I know my camera work is terrible tonight. I'm sorry, it's late. I want to get home. But up into here. And then back over through the firewall. If I can get you a picture down here. Back through the firewall, through that garment to the BCM. So we've got maybe 10 feet of wire, maybe. So you really want to look over the harness very well. I mean, really pay attention to it. And I think I already know where my problem is, or where this customer's problem is. And if you guys really pay attention to my channel, probably a week or two ago, I posted a short of like a YouTube short video of a wire harness that was damaged on another 2008 Chevy truck, and it was damaged right there. Don't know if you guys can see that, but yeah, this is a stud under here. It's got a bolt sticking out of it, and this harness is sitting on top of it. I feel like that's where my problem really is. Even though that harness over there looks bad, I think my problem is right there. So I want to crank it, get it running, get the scope rolling. I want to press on that harness just a little bit and see if we get some activity going. All right, swap my lead around here. Got it plugged up here, and we know we're gonna catch it when we start this thing, so we'll just make sure we do. Yep, right there. Okay, and see how it went away. So we know we caught it. So let's go out here where we can see this harness and do some pokey testing. Try to get you guys where there's not a glare. Probably not going to happen. So we're still not got anything, so I'm going to just take and just push on this harness a little bit, just give it a little wiggles. I'm not really seeing anything. Not seeing anything. It definitely feels like that is poked up through there though. But yeah, we're not getting any activity there. So is it like that other truck where I'm pretty sure that thicker, I think it was a purple cable that was chafed in there, was the starter wire, like the control wire to the starter? What's the odds of that being what's basically chafed into our battery sensor? Possibly. I don't understand why it's not wanting to act up all the time again, but let's lift that up, look under there with a mirror. Alright, so let's see if we can get in under this and look. Come on. Definitely got some wire damage in there, guys. Definitely some wire damage. Let's see. Let me zoom you guys in there. Come on. If I can get my fingers to work again. Do you guys see that? Come on, focus in the right spot. That sure does look like a pink wire, a yellow wire, and a purple wire there. So, I think it's safe to say this is where our issue is. Got it cut open here to where we can see, and that is definitely a pink wire there. The purple starter wire, and I'm not sure what that yellow wire is there, but the yellow wire might be 12 volts too. So yeah, I think we found a problem. But anyways, it's getting late. My phone's actually about to die, and so I'm going to get these wires fixed, get this all fixed back up. I'm going to replace that stud with just a regular 10 mil bolt. That way it can't work its way through again. I don't understand why this harness, in the last truck harness, neither one of them had the little standoff clip thing. This right here. Of course, this one's all the sheathings broke off of this, but this is supposed to be around this to keep that secured there, and neither one of these trucks had that. I don't know if that was a mishap on GM's part a long time ago or what, but I see most of these trucks have that clip there. But anyways, this was a crazy one. Let me know, guys, how would you guys feel about the BCM? Is that on you? Is that on the customer? Would you ask GM to warranty it? You know, the problem I have is the guy bought the truck this way. All he knew is the dome lights didn't work. And it's crazy that BCM still cranked and drove and could see some data, but yet this is what killed that BCM. I guarantee it. Just killed it in a different way. So, yeah. I don't think it's on the guy. I mean, to basically pay for 2 BCMs. It's not right for me to basically pay for 2 BCMs. And really, it's not right for GM to warranty the BCM because it wasn't defective. Something was wrong with the truck. Granted, the truck is what caused the BCM to go bad. I'm not really sure. Everything looks stock under this thing. Nothing really looks out of place. So it's way out of warranty. If this happened while the truck was under warranty, yeah, GM would have definitely paid for that BCM. They would have paid for the first one. So I'm not real sure. Not real sure how to handle this one, guys. I know the extra labor time to diagnose this issue, I'm actually thinking that it's probably tied in with his StabiliTrak. I'm going to see if I can figure out what that yellow wire is, but I feel like it's all going to be related. So diag time, it's all going to fall under that. So it's just it's a crazy situation. And really, it's a shitty situation for me, for the customer. I don't know, guys. What do you think? You think the customer should pay for 2 BCMs? I mean, yeah, he's paying for the diag time. Do you think I should ask GM to warranty it? I'll see. We'll see. See where it goes. As of right now, I'm covering a second BCM. It's coming out of my pocket. Chalk it up to cost of doing business. Retaining hopefully making a good customer, making him happy. I'll break even on the truck. I'm not going to be losing money on it. I'll break even. So let me know down in the comments what you guys think. And very crazy, very crazy. But thanks for watching, everybody. We'll see you guys later.